Basically, so far, what type of graphs have we been focusing on? Parabolas, right? X squared is somewhere in the equation. Sometimes we've looked at x cubed, but so far it's been x squared. Today we're looking at a graph or a function where it's 1 over x. So x is at the bottom of a fraction, okay? And this type of function forms what we call a hyperbolic function. So here's some features of a hyperbolic function. They have this thing called an asymptote. An asymptote is where the function never reaches. Another feature of a hyperbolic function is it may not have an x or y intercept. So this is what a hyperbolic function looks like. And so the function heads towards x equals 0, but it never actually gets to x equals 0. And this is the asymptote. This line here is x equals 0. It heads towards it, if you follow the blue line, but it never actually touches x equals 0. In the same way, it heads towards y equals 0. So if we go back the other way, it's going towards y equals 0, and then it scoops. It never actually touches the y equals 0 line. This is called the other asymptote. So I've got a graph for you. I want you to think about what's happened to the graph. Compared to the original graph, how is this one different with the person next to you? It was there, and now it's swapped to there. It's moved. What do we call that in mathematical terms? We have translated it. So this is the y-axis, and this is the x-axis. I know, it's not a great diagram. And these grey ones here, what are they called? Starts with A, the asymptotes. So in this example, the asymptote here is at what number? 2. Y equals 2 is one of the asymptotes. What's the other asymptote? X equals 3. So these are the numbers the graph is approaching but never touches. So this is what the equation looks like. Y equals -1 over x minus 3 plus 2. On the line, the x asymptote is the number on the denominator, right? So it's -3, but in the graph, the asymptote is +3. So it's the opposite sign. Okay, that's the first thing. Where on the graph does it tell you the y asymptote? So it's the number outside the fraction, right? So in our original graph, there was no number outside the fraction, so it was y equals 0. In our original graph, there was no number added to the x, right, on the denominator, so it's x equals 0. Those were the asymptotes. Now we've got numbers. The last thing, what does the -1 do? So it flipped. We call them quadrants 1 and 3. So it goes 1, 2, 3, 4. So it was in 1 and 3. Now it's in 2 and 4. So the -1 flipped the quadrants. Okay? So these are the main things you need to write down today. Those specific features, I suppose. So write down all that stuff, working out the features. All right, I'm just going to do B before you're going to have a go. So I'm going to have a go at getting the x and y intercepts from the graph. So just like year 9 and 10, how do I get an x-intercept? So y equals 0, and now what do I do? Yep, solve it by rearranging, right? So bring the 2 over, we didn't get to domain and range. So, if you can write this down, the domain of the hyperbolic function. So every number is included, all real, except that number there. Because that's starts with A, asymptote. It never touches the asymptote. So x is every number. It could be negative a million. Could be negative 1,700.69532. But it's not that number there. That's what this slash means. X is an element of reals, except that. The range, Y is an element of reals, except for this number, because that is the Y asymptote. So we're trying to figure out the domain of, so we're trying to figure out the X values. So in this here, what can not equal 0? The bottom of a fraction cannot equal 0. The bottom of a fraction cannot equal 0. Because 6 divided by 0 is impossible. Okay, so then we can rearrange this to figure out when x does not equal something. So bring the 2 over. So minus both sides by 2. Divide both sides by 3. So x cannot equal negative 2 over 3. If I substitute in negative 2 over 3 for x, it won't work because the bottom will equal 0. So the domain is x is an element of what? X is an element of real, except negative 2 over 3. So y is an element of reals, except it cannot equal 0. Because if I substitute 0 in here, I can't get an answer for x. It doesn't work.